In this video, I'm going to discuss network architectures and specifically an architecture known as the collapsed core and another architecture known as three-tier architecture. This video will cover CCNA Objective 1.5, compare and contrast collapsed core and three-tier architectures. Before we get into the specific network architecture designs, we need to familiarize ourselves with Cisco's hierarchical internetworking model, which divides a network into three architectural layers: core, distribution, and access. Each of these architectural layers focuses on a specific task of the network. The core layer provides high-speed backbone switching. The distribution layer provides connectivity and forwarding of traffic between the access layer and the core layer, and also is where WAN connectivity is provided. And finally, the access layer provides the connection point for user end devices. Using a hierarchical network design breaks the complex problem of network architecture into smaller, more manageable problems. Each level or tier in the hierarchy addresses a different set of problems, and this helps the network architect optimize network hardware and software to perform specific roles. The overall effect of using this design is that it increases performance, makes management and troubleshooting simpler by being able to isolate faults, optimizes the creation and application of filters and policies, and it makes the network more scalable and also more resilient through redundancy. How these three architectural layers are actually built into the network design depends on the network requirements and the budget constraints of an organization. So let's take a look at our two most basic types of network architectural design. We'll start with the three-tier architecture. In a network built with the three-tier architecture, all three layers of the hierarchy are present. The core is aggregating the distribution layer switches over redundant links and providing high-speed switching over the backbone. In this example, there are two core layer switches, but there could be more. As the network grows, more switches could be added to connect to more distribution layer switches. And the core layer switches can be connected in a full or a partial mesh. The physical location of the core switches is really irrelevant to the example. They could be in a separate building or housed in multiple buildings, but what's critical is there is a defined set of core switches and that they connect usually through redundant links to the distribution layer. Now, the distribution layer is providing an aggregation point for the access layer switches in each building over redundant links. The access layer switches would have connections to each user workstation in the building or maybe to a wireless network. Note that there are no direct connections in this particular architecture between the buildings. In other words, the distribution layer switches are not interconnected to each other. Each building or each set of distribution layer switches has to connect to the core. What that means for user traffic is users in building 1, if they're going to communicate with users in building 3, their traffic has to go from their access layer in building 1 to their distribution switches out to the core, and then from the core to the distribution switches in building 3, and then the access switches in building 3, and then to the end users in building 3. In a network built with a two-tier architecture, which is also known as a collapsed core architecture, there are no dedicated core switches. All the functionality that the core layer provided in the three-tier design is collapsed into the distribution layer switches. This means the functions of all three layers are still being performed, but there's just no actual dedicated core switches. The distribution layer switches are doing the job of both the distribution layer and the core layer. So which design is better? Well, as with anything in networking, there are advantages and disadvantages to both types of designs. The three-tier design requires a separate core network with very expensive core switches, but it doesn't require as many links to connect to the distribution layer. Note that in the three-tier example, each distribution layer switch requires only 2 links to the core. So in the three-tier design, we do have dedicated core switches, which are expensive, but we have less actual port density between the distribution layer switches up to the core. The two-tier design, while does not require the expensive core switches, has more links or more port density connected to the distribution layer switches to create a full or partial mesh of redundancy. Also note in the two-tier example, each distribution layer switch has 4 links. So in the two-tier design, it might be more cost-effective for smaller networks, but as the network grows in the two-tier design, the distribution layer port density grows exponentially, increasing cost and complexity. At some point, the two-tier design will actually become more expensive than the cost of having dedicated core switches in the three-tier design if the network scales large enough.